Okay, good morning. Welcome back. Just handed back our third test. The median on this test was an 85, which is quite good. So our third test is behind us. At this moment, almost all of the grades are behind us. All that we have left is a quiz coming up. That's a week from today. We have a project that is going to be due on the day of the final, but if you have time to do it before then turn it in anytime, really. It's just kind of a reflect on the semester project. And then finally, the final exam, which is on May 18, which is 2 weeks from today. This course will be done 2 weeks from today. In terms of understanding what your position is in this class, all right, so on the test that I just handed you, I gave you your snapshot grade. If the class were to end today, here's what you would get. But at this point, I'm happy to play a more particular game with individuals. See me outside of class if you'd like to play this game where you say, okay, Ian, what do I need to get on the final in order to get a D or a C or a B or an A? And we can just tweak and fiddle and eventually figure out like exactly where you are. Of course, it's pending a quiz and a project, but they won't change the grade that much. Really, the final is the biggest thing that could either bump you up or push you down. So see me after class or any day before class, just outside of class if you'd like to play that game. In terms of the material left to cover, there's not a lot of time left in the semester. We have today, we have a full week next week, and then we have Monday. And that's the last day of the semester for all classes. Monday, not this coming one, but a week from Monday is the last day of classes. So today, so here are our 4 days of new stuff. We're going to introduce something called the conic sections. They have a lot to do with cones. We're going to spend a day talking about circles, another day talking about ellipses and hyperbolas, and then finally one day talking about parabolas, and then sort of wrapping things up with this little mini theme section here. And then finally, the Monday, last day of the semester, we'll spend reviewing for the final exam. Any questions on the schedule? Okay, so last thing while the calendar is up here, I had planned to do something with you guys outside today, but the weather is not permitting us to go outside today, so we're going to swap. What it says here is 37 and 38. Okay, so we're going to jump ahead past that class. I think Monday is going to be sunny, so we'll go outside on Monday, meet here, and then we'll walk out together a little bit into the class. But we'll jump to page 48. So the homework assignment for tonight is going to be a little bit off from what the calendar says, but we'll figure it out. Okay, so today is about circles. Let's go to number 1. Can we start with Stephen? Okay, so we've done questions like this before. You could do, for example, x equals cosine of t and y equals sine of t. You could swap the sine and the cosine. You could make one or both of them negative. There's lots of ways to do this, but there's one way. We'll go to Garrett for number 2. Just read off the board.
How do we parameterize the circle of radius 3?
Okay, so there was something in the equations in blue there that said the radius of the circle is going to be 1. What is that something? Well, you guys can tell me that cosine is definitely always less than what number? Always less than 1, and always more than negative 1. So the x is definitely trapped between negative 1 and 1. It cannot get any further than that. That's why the radius is 1, is because cosine goes up to 1 and down to minus 1. So left and right, we go 1 minus 1. Top and bottom for the y value, sine is trapped between 1 and minus 1. So if I wanted to make the radius 3, okay, I'm going to copy it as it was. Y equals sine of t. But can you guys put something in here so that instead of going up and down to 1, it goes up and down to 3? Would a plus 2 take care of it? Like I could add 2 and that would make a 3, right? Yeah, but it wouldn't make this a negative 3. So how do I make it a 3 and minus 3? I multiply by 3. 3 times cosine. That bounces between negative 3 and 3. And 3 times sine. So that will give me a circle of radius 3. Okay, let's try number 3, Topher. Okay, let's see. So my radius of 3, I feel pretty comfortable with the one that we have above, so I'll copy that one. And then I want to center it not at the origin, but at 4 and -1. Okay, let's see if we can figure out how to do that. At the moment, this guy right here is trapped between 3 and -3. But I don't want it to be trapped between 3 and -3. Where do I want the center to be for the x value? I want the center to be at 4. So picture now in your mind a circle where the center is at 4 and the radius is 3. So go left and right 3 from the middle number of 4. How big do you get? 7. And how small do you get? Okay, so then somehow I know, just by thinking about the picture of my circle, that I got to be trapped between 7 and 1. And that 7 and 1 is just 4 plus 3 and 4 minus 3. Starting at 4, go out the radius. 3 left and 3 right. Okay, so how do I make 3 times cosine of t go between 7 and 1? What do we do?
I would just add 4.
What if we add 4? Take a look at what it used to be. It used to go from -3 to 3. We just added 4 to those numbers. What does -3 become? 1. What does 3 become when you add the 4? 7. That's how you do it. We want it to be centered at 4. Okay, put a +4 there. What was in this space, even though I didn't write it? Plus what? +0. That's why it's at the origin. You don't have to write +0, but whatever you put there is going to be the center. So then what should I put down here on the y value? And put a -1. That's how we're going to center it at -1. And so, of course, we could check any of these things. You don't need to do this, but just so you've seen it. Back in parametric mode, I'm just going to type in my 3 cosine of t plus 4. And then 3 sine t minus 1. And hopefully we'll see a circle. Radius is 3, centered at the point 4, -1. That seem reasonable? 4, -1 looks pretty good. Out 3, over 3, up 3, down 3. So that's how we do it. Okay, Topher. Where? Like here? All right, so it's going to be cosine of t plus 4. Thoughts? Start at a different point on the circle? Like an ellipse, maybe?
Well, they're both adding the same number. They add different numbers.
Oh, okay. All right, so hold on. So were you saying add the same number, or were you saying maybe just one of them?
Well, I was just saying,
Okay, so first let's try Garrett's suggestion of maybe adding the same number. And Garrett thought that maybe this would be the same picture, but just starting at a different point. Well, let's see. Normally we're going t is 0 to t is 2 pi. But if you plug in 0 for these t's, you get 4, which is just not the original point on the circle, but some other point 4 radians into the circle. So the circle that we had before, I think started here on the right-hand side. This one starts at some random place in the 3rd quadrant. How come? Because that's where 4 radians is. Okay, so I like that. Let's go back and we'll just delete this guy, but then we'll keep that one as a +4. So now they're different. What do we think? Garrett says a weird swirly shape.
they're not locked to each other anymore. So one's going to go up, it's just like they're not. Oh, weird. Expecting a lot of strangers on that.
I think everything you said is right. They're not locked to each other. like cosine of t and sine of t are perfectly joined. We had that sine squared plus cosine squared is 1. That's what made it a circle. But it's not sine squared plus cosine squared anymore because they don't have the same angle in there, same input. And so they're really like not related to each other in that nice way from that equation. And so we get this kind of crazy, you know, like one's going up and we expect the other one to be curving nicely, but instead it's going the wrong way. Y equals, so if we change that to a t minus 4, plus 4, so you can change them both, and I think we'll get kind of different crazy this. Like different looking crazy swirly type things. Okay. All right, so that's good. Good questions. How about we go to 4 for Kelsey? Okay, can you guys try to generalize what we did right above? Give me 2 equations, x equals y equals, should have r, should have h, should have k. Okay, what do we put? R cosine of t is still the same t, but where does the h go? Is plus h. I'm actually going to write it this way. It makes no difference, but I think in the next section we write the h in the front, so I'll just start writing it in the front. And then the other one, k plus r sine t. There we go. Any center you want, any radius you want, that's how you parameterize it. And we'll go to Ali for 5. Okay, implicit means what? Y equals or all mixed up? There's implicit and there's explicit. Which one is implicit? Is not the y equals. They're all mixed up. If you can solve for y explicitly, then that's called an explicit equation. So let's get an equation for a circle. Now, some of you guys might have already seen the circle, so you might know what's coming. And if not, then it'll be a pleasant surprise. But we're just going to get some equation with x's and y's for this general circle. Okay, we know that sine squared t, in fact, I'll write the other one first. We know that cosine squared t plus sine squared t is always what? 1. Our job is to build that equation. We need to build that from the blue equations we've got up above. Which means what I'd like to do is get the cosine of t by itself so I can square both sides. I don't want to square both sides right now. Square both sides, you get a mess. You have to FOIL. So let's get that cosine t by itself first. So how do we move the h? Subtract it. So we go x minus h is definitely r cosine of t. And again, the goal was to get cosine by itself. So what do we do to move the r? Divide. So we go x minus h over r is cosine. So that means if I square both sides right now, then I finally have something with a cosine squared in it, which is what I'm trying to build. Okay, we can follow the same pattern with the second equation. I'm just going to jump to the end with the second equation. When I square the right-hand side, what will it end up being? It's going to be sine squared. Can you fill in the parentheses using the letters from the bottom equation? You got y, k, and r. Where do they go? So it becomes y minus k over r, right? So we did all that work so we could get cosine squared by itself, sine squared by itself. What are we about to do to these two equations? Add them up because we're trying to get cosine squared plus sine squared. So if we add them, I'll just write the left-hand side. This is just copying. X minus h over r squared plus the other guy, y minus k over r squared. 3 equals 1 because it's equal to cosine squared plus sine squared. So there you go. There's no more t. We've eliminated the parameter. This is an implicitly defined equation for the circle. X's and Y's all mixed up. Now that's not the standard form equation for a circle, so let's just go a little bit further only because that's not the way we normally write it, but it's perfectly legitimate to write it this way. I'm just going to write this. I'm going to square the top and square the bottom separately. And then I'm going to clear the fractions. What should I multiply everything by? R squared. That will get rid of all the denominators. If you multiply the first thing by r squared, you just get the top, x minus h squared, plus, if you multiply the second thing by r squared, you just get the top again, equals, so we had to multiply both sides by r squared, so what do we get over here? R squared. That's the standard way to write the equation of a circle. Raise your hand if you've seen it before. It's like maybe half, a little more than half of us. So at some point, if you saw an equation of a circle, it was probably this one, although potentially you saw the simpler version of it, which is x squared plus y squared equals r squared. It's a circle. What's the only less general thing about that circle? It's centered at the origin. That's all. So the one that we have down at the bottom in the green is the general circle. Any center, any radius, that's the equation. Okay, Allie, did you read? Yes, you did. Steve? Okay, can you guys plug into that bottom formula we just created? Okay, what goes in the first parentheses? Yeah, it's going to become an x plus 2. I'll go ahead and sort of naively just put x minus the center, x minus negative 2. And the second parentheses, 7, and the end, 25. That's 5 squared. So that's the equation of that circle. Questions on how to use the formula? No need to FOIL it out. But if we did FOIL it out, just imagine what it would look like. You'd have x squareds plus some x's plus a number plus, and then you FOIL the other guy, y squareds plus some y's plus a number equals 25, right? Okay, so 7, Ernie. I want to change that because that's a lie. X squared and y squared need to have the same coefficient. Sorry about that. So for example, maybe you have something like that. Somebody has FOILed the equation of a circle, and they got some x squareds, and they got some x's and a number, and some y squareds and some y's and a number, and that was equal to the radius. Is the radius 0 in this case? No, I mean, there's actually, that -3 right there contains like the FOIL for the x's and maybe the FOIL for the y. Like there's a bunch of constants floating around, and there's an r squared, and maybe they got all mushed together, and you got -3. So what do you think I'm going to ask you to do? Taking a standard looking equation of a circle, but somebody's foiled it and gotten that. We're going to unfoil it. We're going to try to figure out what is it really? I'd really like for it to look like x minus something squared plus y minus something squared equals something squared. If it looks like that, then I know everything about the circle. I know the center. I know the radius. It's easy. I don't really know what's going on with this circle because somebody foiled it. Okay, so what we're going to do is unfoil. Number 8. We are back to Todd. Okay. We didn't do any completing the square this semester, did we? Last semester? Okay, a little bit. All right. So there's a process. It's written out. We're going to say it in English anyway. So how about we just dive in and start using the process? So number 9. We've got x squared plus 6x plus 2. What I'd like to do is complete the square. Here's the process. I'm going to copy the x squared, and I'm going to copy the 6x. Then I'm going to leave a little space. I'm going to copy the plus 2. And inside of that space, we have to put the magic number, the right number. Turns out there's a little nifty formula you can use to figure out what to put in there to make a perfect square. Does x squared plus 6x plus 2, does that factor? You know, like maybe it's like x plus 3 squared, or like, is it? It's not, right? Okay, so it doesn't factor. I was really hoping it would just be a perfect square. It's not. So you got to find the right magic number to put in the space to make it a perfect square. So here's what you do. You take b and divide it by 2. B is which number? 6, right? You know the ax squared plus bx plus c. So you take 6, you divide it by 2. Right, that's just 3. But you don't put 3 there. You square it. So square that number, and we get 9. So the magic number is 9. So what I'm going to do is put a plus 9 right there. To get that magic number, it's always the same. Half of b and then square it. That's it. But I can't go around just adding 9 randomly to my thing. What do I need to do? I need to right away subtract 9. Otherwise, the scales don't balance anymore. Is this equal to what it was before? Now it is. I added 9. I subtracted 9. I haven't done anything, but if I just look at this guy, it factors. Go ahead and factor x squared plus 6x plus 9. How does it factor? X plus 3, x plus 3. So it's really x plus 3 squared. That's what I wanted. I wanted it to be a perfect square. By putting that plus 9, that magical number, you found the only guy you could put there to make this factor into a perfect square. And then there's just bookkeeping out at the end. Plus 2 minus 9 is a minus 7. That's all. Questions on that one? We'll get to it. Okay, let's try B. Y squared minus 5y minus 3. Same process, but this one is slightly more annoying. Y squared minus 5y. I'll leave my space. And then we'll do our little magic calculation up on top. What do we do? Okay, so we take b divided by 2, so that's a negative 5 divided by 2, and we square it. And so you could either say it's 2.5 if you like decimals, or just leave it like that and then square it, you get 25 fourths. or 6.25, either way. So it's the same process, it's just a little more annoying because you have fractions. So what do we add in the space? 6.25, or I'm going to leave the fraction, 25/4. So what do I do to balance the scales? Minus 25/4. Okay, whatever you did, added it, or subtract it right away. I added it, yeah, so when you do that squaring thing, you square everything, including the negative, so it's always going to be a positive. I added 25/4 here, and I need to make sure that I got to undo adding 25/4. But what you might be thinking of, Ali, is if we had this equation, y squared minus 5y minus 3, if it was equal to 0, then you could say, okay, I'm going to add 25/4 to this side, and I'm also going to add 25/4 to the other side. So that's, if you have an equation, you're allowed to add the same number to both sides. But we just have expression here, so we'll do the opposite of the adding, so we'll subtract right away. Okay, also slightly annoying, but this guy turns out to be a perfect square. This guy. We don't have a lot of practice factoring things where there's a fraction sitting at the end. I'll give you a little shortcut here. There is a magic formula for what goes in here. It is always y plus b over 2. That's the thing that goes in the parentheses. Every time. Before we do it on that one, let's check over here. How much was b over 2 for our first example? It was 3. Positive 3 or negative 3? Positive 3. And what ended up in the parentheses? A positive 3. It's always b over 2. Okay, I can deal with that. So in here we go y plus, how much is b over 2 in this case? Negative 5/2, or negative 2.5. That's what goes in the parentheses. If you FOIL that, you'll see it gives you exactly what we wrote up above. Okay, and then out here, more bookkeeping. Is that negative 37/4? Questions on that one? Okay, so now we get to Topher's example. So if you don't like the way this one goes, you can blame him. All right, how much is half of b? 3, and then you square it, 9. Adding 9 is not going to get you the right answer. So Topher makes the observation, what if a is not 1? Well, if a is not 1, there's another step you need to do. You got to do it first. You have to factor a, well, so first let me, I'll write down the first two things with my space, 3x squared plus 6x, and my space, and plus 11. But before I fill that space, I need to make it so it's really just x squared. I can't handle this 3 in the front. At least that magic formula doesn't work when it's just 3 in the front. So you're going to factor that 3 out. 11 I don't care about, it's just sitting out there. So what do you get in the first spot? X squared plus, factor the 3 out here, 2x. That's what we need to do.
You know, like, I feel like just looking at it like that doesn't necessarily make sense, but like when you think about the fact that you're going to be boiling it, that really would be applied against the sides.
That's right. That's a good way to think of it. Okay, looking in the parentheses, we need to do half of b. How much is it? 1. Then you square it. 1 again. So we're doing b over 2 squared, 2 over 2, just 1, plus 1. If I add 1 right away, I need to subtract 1. Subtract 3? We added 1. Why do you want to subtract 3?
Actually multiply 3 times.
Yeah, that. All right, so let's get rid of this because there's some controversy. But that plus 1 in the parentheses, is it really a plus 1? Not really. It's really a 3 because there's a 3 on the outside, right? You can't just randomly add a 1 inside of parentheses. You got to ask yourself, what did you really do? You really added a 3. And then we kind of preemptively factored the 3 out. So that 3 multiplied by the blue 1 that we put in there tells us what we really did. We really added 3. So if we need to undo it, we're going to subtract 3. You could leave it in there, but I don't think it's going to be part of the, so like the goal is to get some perfect square, right? And the 11 has nothing to do with what's going to end up as the perfect square. So that's why I toss it way off to the side. Okay, and now we're ready to factor. There's a 3 in the front. You're going to factor the thing in the parentheses and a plus 8 at the end. Okay, what do we get here? X plus 1. That's right. 3 times x plus 1 squared, and then plus 8.
Am I remembering correctly that the vertex or whatever?
Yeah, so if we're thinking of the vertex of a parabola, you guys remember parabola stuff? So our vertex formula was something like this: ax minus h squared plus k. And the vertex was at h comma k. So how much is h? H is negative 1 in this case. To turn that into a plus 1. And how much is k? Is positive 8, is just 8. So that's right, the vertex is at negative 1 and 8. It's a nice connection to make because it's the same kind of thing. I mean, this is where you completed the square last semester. And so you could find the vertex of a parabola when it wasn't in a nice form, like originally. But it always bothered me. Like this formula always bothered me. The x, you got to change the sign, right? That plus 1 next to the x means it was really negative 1. But the plus 8, well, that's really why. You just copy it. It's so weird. Why is there a minus in the one and a plus in the other? Like just one more thing to memorize, and it didn't have a whole lot of meaning until you recognize that actually solving for y is a pretty artificial thing. We do it so we can type the thing into the calculator. That's why we solve for y. But if I don't solve for y, if I move that k over to the other side, I get this. Y minus k equals a x minus h squared. Yes? So they're both minus. They're both the same. They were both the same the whole time. We just artificially made them look different by solving for y. X minus h, y minus k should also remind us of the circle formula that we just figured out. It's the same. So it's actually always minus. All right, so let's try number 10. We're at Sam. Emily. Okay, so remember, somebody took the nice normal equation form of a circle and foiled it all out. So now it's fairly well useless in this form. I'd like to put it back in my useful form. That was this form that we had down here in green. That's the goal. X minus something squared plus y minus something squared equals the radius squared. So how do we do it? Well, we're going to complete the square. First thing to do is maybe group the x's. So I'll go x squared minus 4x, then leave a space, plus y squared plus 6y, then leave a space. And that minus 3 it doesn't belong over there. Let's just shove it to the right-hand side, and it becomes positive 3 by adding it. Does everybody see all 5 terms? Just written in a more beneficial way to us. Put the x's together, put the y's together, Any constant can get shoved to the right. All right, can you guys with your neighbors complete the square how many times? Twice. You have two different squares to complete. So one difference to think about here, because we had an equation, you can see I added my +4 and my +9. Up above, right away we'd subtract 4 and subtract 9. But because it's an equation, you're welcome to add 4 to both sides. And so you can see in red, I put a +4 on both sides. Maybe this is what Ali was remembering from last semester. You add a green 9, okay, add the green 9 to the other side. Either way, it's fine. You just need to balance the scales. And then you collect and you factor and we get that equation. So what is the center of my circle? 2 and -3. Don't forget that all of those numbers are the opposite of what they really are. Because in the formula is an x minus h and a y minus k. So grab the opposite of those numbers. The radius is how much? 4, because that 16 is the radius squared. It's some number in disguise being squared. Okay, and so you cannot type this equation into your calculator. What kind of equation is that? Implicit or explicit? That's an implicit, so calculator can't handle it, but GeoGebra can. So let's try typing this guy in. I'm just going to type in x squared plus y squared. This is probably way too small for you to see, right? Options, font size. Okay, somebody help me out. What was the next thing? Okay, what does it draw? It draws a circle. What does it look like the center of this circle is? You can read it off your paper if you want. 2, -3, and the radius. I mean, like I'll just actually plot the point 2 and -3. So there's the center, and if I look at the axes, nope, I like those. If I look at the grid, then how far is it going from here all the way to the right? 4, and from the center up, it's 4. And in fact, I don't know if you noticed, because it's kind of cut off here. Is this what I typed in? No, but automatically, the program knows that what I typed in is pretty useless, so it does the completing the square and fills it in. Yeah. Okay. Yeah. All right. So we have 30 minutes, which I think is enough time to do this happiness activity. Just one last thing while I have everybody here. So the homework is going to be a little bit screwy because we're swapping 2 days. So can you jump to this page, whatever this page is? 52. Jump to page 52. Okay, so this is the homework assignment for tonight. This is the stuff that you're going to do for Monday. No big surprise there. In terms of reading and preparing for next class, well, it's actually the class before this one that we should be preparing for, and there wasn't any preparation for today, so there's no reading and there's no questions of the day for Monday, okay? But down here, the questions of the day, what do you think about them? When do I want you to do this? This is for Wednesday. Because this whole thing we just did today was supposed to happen Monday. Clear? So I'm not giving you any extra work, just shuffling around the work. Okay, let's see how far we can get on that activity.